Good morning, Math Dragons, and welcome to a new week. We have every graph tells a story. Hopefully you still have this in your binder. If you don't, I also posted a PDF for you online, and I posted some Google Slides online. So if you have the ability to print, you should be able to get this. I am going to be doing some cutting and pasting because we're matching some graphs today. And this is our mini lesson as an introduction. So this is part of the equations unit, but it gets a little more complicated. But graphs can be really fun. The vocabulary can be challenging. So I posted a YouTube video that's just 2 minutes long that describes these two things that are super important. We've got some key terms here, but the mini video on YouTube with discrete and continuous graph, it describes discrete data and continuous data. And I think this is very powerful. Discrete data can be counted, and continuous data can be measured. So watch the 2-minute video, get familiar with that. We're going to skip over the getting started. We're going to go right into activity 1.1, match and analyze. As you can see, I had some supplies with me. So I'm going to be using red and blue for my colors. I do have a ruler. You don't really need a ruler. I need a ruler to demonstrate. And some scissors. So it's 1, 2, 3, 4, 5 pages. I'm going to cut these out real quick. Just making sure they line up before I start chopping. Don't chop those. Do chop these. Chop only the graphs. The scenarios do not get chopped. So I'm going to have a pile of graphs. And I'm going to have a pile of situations. And we are going to be saving these to store them in our interactive notebook later. So if you do have these in your binder, fantastic. Many people do. Or if you can print them, also good. So that you too will also be able to keep them in your interactive notebook. Remember, our goal of our interactive notebook is to have all the material you'll need to be prepared for the 7th grade. Trying to keep you on track. Okay, now we have a bunch of graphs and a bunch of scenarios. Now, I'd like to show you how to attack this. Let me see if I can lay out these graphs for you where you can see them. Dun, dun, dun. Okay, A, B, C, D, E, F. We've got 6 graphs. Let's see if these straighten out for you. Okay. I like to look at the graphs first and try to figure out what they're telling me. Because when I was young, graphs were hard for me because I didn't understand what they were trying to say. So the first graph, I see something rises and then something falls. Okay, so could be an object, could be a basketball, could be some kind of weather. Then this graph starts out high and drifts downward. Maybe something being dropped from a building. This one is linear, but it doesn't start at 0, which I find very curious, which means something starts not at 0, but then is proportional the rest of the way. So it's like in step lock. This one goes up a little, stays the same for a while, goes up more, stays the same for a while. This one is the type we're most familiar with because of ratios and proportions. This one goes straight through the origin. It has a consistent line. It has a constant of proportionality. This one's linear, but it is taking a pretty strong drop. But it appears to be a relatively consistent drop. This one has more of a dramatic drop, and this one is more consistent. So this would be climbing, maybe like every time you sell something, you make money. This one could be a variety of things. I know from the scenarios, though, I believe it to be related to weather. Something that drops continuously could be losing money on a daily basis, like an interest rate. So these are some choices. Now we have all these scenarios. T-shirt, toy rocket, fish, DVD, rainy day, and pool party. Okay, let's start with toy rocket. You launch a toy rocket into the air from the ground and observe its height through its entire flight. How many feet high was the rocket at a specific time after launch? Okay, take a look. Which one looks like the flight of a rocket? What are you thinking? If you thought A, you thought correctly. So A is going to go right in here. Feel free to tape or glue it. We have an x-axis and a y-axis. Our x-axis is generally considered the independent, which means it stands alone. And the y-axis is usually dependent, which means it needs the x in order to go on. So what could be some reasonable labels for the flight of a rocket? Well, it asked, how many feet high was the rocket at a specific time? So I'm hearing feet, like height, and I'm hearing time. Feet and time. All right, so time is generally independent because time is going to move forward no matter what you try to do. Time since launch. And how many feet was the rocket at a specific time? It doesn't really say what it's measured in, but my answer key tells me it's measured in seconds. Now, what are we measuring? Time is going on, 2 seconds, 4 seconds, 6 seconds. What are we measuring? The height of the rocket in feet. Height of rocket. The word problem did tell us that it's measured in feet. Let's take a closer look at that. You've got height of rocket measured in feet, time since launch. So this graph goes with this word problem. Next up. the rainy day one. When you left home, the rain was falling at a steady rate. Then it stopped raining for a few hours before a sudden downpour. Finally, it stopped raining. How many inches, okay, we know a measurement here, of rain had fallen at different points of the day? I'm going to guess that's going to be hours of the day. This is just a guess. I haven't looked yet. Okay, now remember, it's raining, it stops, it rains again. Where is something where the graph stops? This one. Okay, good job. So again, x-axis here. What is being measured on the x-axis? What is the x telling us? It is telling us time of day in hours. What is the y-axis telling us? The amount of rain fallen. Here's your y. It is dependent upon the time. Time is usually independent because you can't change it. So this is going to be the amount of rain. Rain is generally measured in inches, like on weather channels. All right, we've got amount of rain being measured at certain times of the day. It makes sense. It rained a bunch of inches, stopped for a while in the afternoon, rained a bunch more, stopped for the rest of the evening. Excellent. It's easier as we get fewer graphs to choose from. Okay, I'm just going to pick another one. DVD and game rentals. The video kiosk charges $2 for every DVD and game rental. How many DVDs and games can you rent for different amounts of money? Well, since there's consistency and it's $2 over and over and over again, I'm looking for something that has consistency. So every time I sell something, I earn $2. Every time I sell something, I earn $2. This one has consistency. This one, too. But I can make an argument here. If I sell 0 items, am I going to make money? Here, if I sell 0 items, I make no money. So to me, this is the better choice. DVD rentals goes with E. DVD and game rentals. I don't even know if I can do that anymore. Now I'm going to start with the y-axis because I want to point out that you can't earn anything in this scenario unless you sell something. So it's very obvious that money is the dependent variable. So this would be total cost, total money, measured in dollars. This is what? What are you selling? What are you doing? What is your operation? And I don't mean mathematical operation, I mean like business operation. What are you doing? You are renting items. So number of rentals. They did not put measurements for us for money. I don't know if they were trying not to give it away, but it would be 2, 4, 6, 8, because it says the video charges $2 for every rental. So 2, 4, 6, 8, 10, 12, 14, 16, 18, $20. You sell, or rent out rather, 1 and get $2. You rent out 2 and 3, 4, 5, 6, 7, 8, 9, 10. Alright, let's take a closer look at that for you. Number of rentals. Every time you rent something out, you get $2. Or if you want to get 2 rentals, what's it going to cost you? It's going to cost you $4. If you want to get 3 rentals, it's going to cost you $6, and so on and so forth. So in this scenario, it's not so much you're taking money in as you're spending money for the product. T-shirt sales. You buy t-shirts to sell it for your school. There is a $25 design charge plus the cost per t-shirt. What is the total cost for different numbers of t-shirts? So it can't start at 0. Not that any of these do. None of these start at 0. But once you pay for the service charge, your t-shirt costs the same over and over and over again. So which one makes sense? This one. This one makes sense. And I'll show you why. Right here, we can assume that this is $25. They didn't tell us how much each t-shirt costs, but we do know that we have a service charge of $25 no matter what. If these intervals were to be even, and I divided 25 in half, that means each interval would be 12 and a half. So that would be another 12 and a half, 12 and a half, so on and so forth. So it would be like 4 t-shirts cost you $50 if they're counted by 25s. We don't really have enough evidence to know that for certain, but that's just logically what I'm doing based upon the spacing that they did. Remember, money is usually dependent upon whatever you're selling or purchasing. This is total cost in dollars. And what is the product? Number of t-shirts. Sold or purchased, depending on your perspective here. What is the total cost? So you're purchasing, you're not selling. Good. Just 2 more and then we're finished. We're going to go over just a little bit on 20 minutes here. So we got a fish tank draining at a rate of 10 gallons per minute, which is consistent. How much water remains in the tank at a specific time. Or you have cookies for a team pool party, but you don't know how many teammates will show up. So that's totally random. How many cookies will each teammate receive if everyone receives the same number of cookies? But you don't know how many people are there yet. So that causes us all sorts of problems. I like the fish tank one because it says it has a rate. 10 gallons per 1 minute. Well, if it starts at 200 and it drains 10 minus 10 minus 10 minus 10, that would be a nice straight line. So that one makes more sense to me. We're going to pop this one in here. And let's figure out what the axes needs to be. Okay. Remember, X is usually time, and it says how much water remains at a specific time. So we're going with time here. Amount of time draining. Measured in minutes? Minutes. Given in the word problem. And then what is being drained? The water. Hope they took the fishies out. So as time goes by, water goes down. Amount of water in tank. Measured in what? What did it say? Gallons, which is a unit of volume. Excellent. All right, so we know what the last match is. Let's see if we can make any sense of it. The pool party, you don't know how many people are showing up. You want to give out an even amount distribution of the cookies. It's kind of random here. This graph has like a reverse exponential look to it, but it's kind of all over the place. Not loving this graph. Pool party, graph B. This is how many people attend. Number of attendees. Or number of teammates, whichever is easier for you to remember. So if 2 people show up, they get 12 cookies. If 4 people show up, they each get 6 cookies. If 6 people show up, they each get 4 cookies. So I do see a consistency. There must be a total of 24 cookies available, and they're testing out, if this many people show up, how many cookies are they going to get? So what is the Y here? It's the number of cookies for each teammate. Oh, I ran out of space. So again, 2 teammates show up, they each get 12 cookies. 4 teammates show up, they each get 6 cookies. That still adds up to 24 cookies. 6 people show up, they each get 4 cookies. That's still 24 cookies. 8 people show up, they get 3 cookies. That would be 3. That's still 24 total. 10 people show up, they get just under 3 cookies. They're splitting cookies. 12 people show up, they each get 2 cookies, which seems like a more reasonable person portion than 12 cookies. Most people are not going to sit down and eat 12 cookies. Okay, you did an excellent job. You should have all your scenarios ready with your X and Y axes labeled on each of them. I want you to hold on to these, and we're going to talk about these during our session today live. Thank you so much.